The graph of f is given here to the right. Why is this function a one-to-one function? Well, if we look at this graph, we can see that it is a one-to-one because it passes the horizontal line test. Okay, now what are the domain and range of f inverse? Well, the function that we have is f. So here it ends at this point and it ends over here. Now keep in mind here that this is 0, 1, this is 2, and this is 3. This is -1, this is -2, and this is -3. So the domain is all the x values. So the domain is bracket -3, comma, +3. And now keep in mind that the domain is also the range of the inverse. So therefore, this is also the range of f inverse. Now, if we take a look at the range of f, so here we have -1, 0, 1, 2, and then 3. So here we start at -1, and then we end up at +3. So the range of f goes from -1 to +3, which then means that the domain of the inverse is the same thing as the range. Again, this is the domain of f. I want to make sure that was in there. Okay. So now it says, what is the value of f inverse 2? Well, this is the input on the inverse, so it's going to be the output on f. So if we have f of what is going to equal 2. So here we can see that 0 is going to give you the value of 2. So at this point here, this is 0 and 2 on the function of f. So f of 0 is equal to 2. Therefore, if we talk about the inverse, if we find the inverse of 2, then that means the output is going to be 0. Okay, now in part D, we want to estimate the value of f inverse of 0. So that means that we want to find what is, or estimate what is the input when the output is 0. So if you look here, this is when it touches 0. And it's about approximately -1.7, which is close to 2. So we can say it's approximately -1.7. So therefore, f inverse of 0 would then be approximately -1.7.